Suppose I want to solve systematic equations by substitution. Substitution literally means you're going to solve one of the equations for one of the variables and then substitute it into the other equation. So in this example, let's solve equation 2 for x. So x is 1 plus 2y. Now I'm going to take that and I'm going to substitute it into the first equation. So it'll be 4 times x. So 1 plus 2y minus 3y equals 14. Distribute, collect like terms. Y is 2. Now I'm going to take y equals 2 and I'm going to put it into either equation I want. In this case, I'm going to put it into equation 2 so that x is 2. X minus 2 times 2 is 1. So x is 5. Now when we're solving linear equations, graphically, you can see how many solutions you have. They're either going to intersect at exactly one point. If the lines are parallel, they're not going to intersect at all, so we'll have no solutions. Or they may be the exact same line, and these are dependent lines, and they overlap. When two lines intersect at exactly one point, the system is called consistent, and we say that the equations are independent. When the lines are parallel and they don't intersect, we say the system is inconsistent, and we say that the equations are independent as well. Now, when they're the same line, we say that the system is consistent, just like we did when they intersected at one point, but they are dependent on each other. So, substitution is the first method we're going to use for solving equations. So now we need to check the solution into the original equations. So when I plug in 5, 2 into the first system, I get 14 is 14, and that's a true statement. When I substitute in 5, 2 into the second equation, I also get a true statement. So my solution set is the 0.52. Solve the system graphically. You solve both equations for y, and then you graph them, and you can read off the intersection point. And you see that this occurs at the 0.52. The second method of solving is elimination. To use the elimination method, you use multiplication or addition to eliminate or get rid of one variable from one equation. To eliminate a variable, the coefficients of that variable in the two equations have to be additive inverses. And then we add the equations to get an equivalent system. Now, when we're transforming linear systems, we can always interchange the order of equations. We can multiply or divide by any non-zero number, and we can replace any equation of the system by the sum of that equation and a multiple of another. So, suppose I want to solve the system 2x plus 3y is -1 and 3x minus 2y is 18. You see how I'm numbering my equations? I'm going to refer to them. Now, I want to multiply equation 1 by 2 and equation 2 by 3. When I do that, I get the equation 4x plus 6y is equal to -2, and 9x minus 6y is 54. So these are equations 3 and 4. Now you see what happens when I add equation 3 and 4. I see that I've got a 6y in 3 and a -6y in 4. So these are additive inverses. So when I add the two equations, I get 13x is 52, or x is equal to 4. Substituting 4 back into one of the original equations, I'm able to solve for y. So y is -3. So the solution for the system is 4, -3. To do this graphically, you graph the two equations, and you see the point where they intersect is 4, -3. Suppose I want to solve the system 7x plus 3y is -5. and minus 14x minus 6y is equal to negative 10. I can multiply equation 1 by 2 and add the result to equation 2. So when I do that, I see I get 0 is equal to negative 20. This is a false statement. And what this tells me is my system is inconsistent. So the solution set is a null set. Graphically, I see I've got two parallel lines that never intersect. Now suppose I want to solve the system minus 9x plus 3y equals negative 24 and 3x minus y is equal to 8. Let's multiply equation 2 by 3 and add them. When I do that, I see I get 0 equals 0, which is a true statement. So this says that these are dependent equations, and any ordered pair you want is going to satisfy the equation. So these are two lines that coincide. So as long as the point is on the line, it's going to satisfy the system. Now, we can solve applied problems by writing systems of equations. To do that, we need to make sure we read the problem carefully, assign variables to represent our unknown values, and write down what every variable represents. Write a system of equations that relates the unknowns, solve the system, and then make sure you state the answer to the problem and does it seem reasonable? And finally, check your answer. So, in 2015, the average of the median salaries for the position of environmental compliance specialist in Boston, Massachusetts, and in Indianapolis, Indiana, was $68,947.50. The median salary in Boston exceeded the salary in Indianapolis by $7,983. Determine the salary for the environmental compliance specialist position in Boston and in Indianapolis. So let's let X equal the Boston salary and Y equal the Indianapolis salary. We know that the average salary, X plus Y over 2, is $68,947.50. And the difference, X minus Y, is $7,983. So let's multiply both equations of sides of equation 1 by 2 to get rid of the fraction. And set it. Okay, so I have equation 3 is X plus Y is 137,895. We also have the equation X minus Y is 7,983. So if we solve this one for X and substitute in, we can solve for Y, and we get that Y is 64,956. So substitute 64,956 into one of the equations. We get X is 72,939. So the Boston salary is 72,939 and the Indianapolis salary is 64,956. Sometimes we have systems of 3 equations, and we can have lots of different answer combinations. You might have a single solution where all 3 of the planes intersect at a point. They may intersect at a line. They may have all points in common. They may have no points in common. And that may be an interesting representation. All 3 planes may be parallel. One plane may intersect 2, but the other 2 are parallel. They may make this teepee here so that all of the planes intersect another plane, but they don't all intersect each other. 2 planes may intersect, but not with the third one. So to solve a system of 3 unknowns, you're going to want to eliminate one variable from 2 of the equations, and then eliminate the same variable from a different pair of equations. Then you're going to have 2 equations. You're going to have the equation from here and the equation from here. you're going to eliminate another variable from those two equations. And when you do that, you're going to wind up with one variable, and you're going to do back substitution in order to find the solutions for the other variables. So suppose I have the system 3x plus 4y minus 2z is 14, 2x plus y plus 2z is negative 9, x minus y plus z is negative 9. You want to, in this case, we can eliminate y by adding 2 and 3, and we get x plus z is negative 6. Now, I eliminated y, so I need to eliminate y from two other equations. So if I multiply equation 3 by 4, and I add that to equation 1, then that will give me another equation, 7x plus 2z equals minus 22. So I have equation 4 and equation 5, which are in terms of x and z. So now I can eliminate a variable between these two equations. So if I multiply the equation 4 by negative 2 and add it, I see that I get x is equal to negative 2. Once I have x, I can back substitute for z. So I can get z is equal to 4. Now I can take my x and z, plug it into any of the other two equations, and solve for y. So my answer is negative 2, 3, negative 4. Now, solve a system with an arbitrary z in there. So we're going to want to multiply equation 1 by negative 2 and add it to equation 1. And that gives us negative x plus 5z is equal to 8. And now solve equation 3 for x. So x is 5z minus 8. So now I'm going to substitute 5z minus 8 into equation 2 and solve for y. So with z being arbitrary, the solution is 5z minus 8 minus 13z plus 17 and z. So let's find the equation of a parabola, ax squared plus bx plus c, that passes through the 3 points, negative 5, 7, negative 1, negative 2, and 3, 5. So the 3 points have to satisfy the equation. So we're going to substitute each ordered pair into the quadratic to get a system of equations. So when I put in negative 5, 7, I get 25a minus 5b plus c is equal to 7. Because everywhere I have an x, I'm going to put in negative 5, and the y value is 7. Now I'm going to substitute in negative 1, negative 2, and I get a minus b plus c is negative 2. And finally, you substitute in 3, 5 to get 9a plus 3b plus c is equal to 5. So now we're going to multiply equation 2 by negative 1 and add the result to 1. So that's going to eliminate c. So I have 24a minus 4b is 9. So this is my fourth equation. So now I need to eliminate c again. So I'm going to multiply equation 2 by negative 1 and add to 3. So I get 8a plus 4b is 7. So now I have equation 4 and equation 5, and I need to eliminate a variable between them. So let's just add the equations, and that will eliminate variable b. So solving this, I get a is 1/2. Once I have a, I back substitute. And I get that b is 3/4. Now that I have a and b, I substitute those into any of the equations I want, and I can solve for c. So the equation of the parabola is y is equal to 1/2 x squared plus 3/4 x minus 7/4. So the table shows a number of units of protein, fat, and fiber in 1 unit of each ingredient in an animal feed. How many units of each ingredient should be used to make the feed that contains 35 units of protein, 38 units of fat, and 28 units of fiber? Hmm. So let's let X equal the number of units of corn, Y equal the number of units of soybean, and Z equal the number of units of cottonseed. Since the total amount of protein has to be 35 for the first row, we get 0.25x plus 0.4y plus z is 35. That's our first equation. Since the total amount of fat has to be 38, the second equation is 0.4x plus 0.2y plus 0.3z is equal to 38. And since the total amount of fiber has to be 28 units, the third row is 0.3x plus 0.2y plus 0.1z is equal to 28. So this is what our system looks like. Now we're going to multiply both sides of the equations. Let's get rid of the decimals. So we're going to multiply everything by 10 or 100 so that now we're dealing with whole numbers. We just make fewer mistakes when we're dealing with whole numbers. Now we need to eliminate some variables. So let's multiply equation 5 by negative 20 and add to equation 4. And when we do that, we could get equation 7, which is minus 55x minus 40z is equal to minus 4100. Now let's multiply equation 6 by negative 20 and add to 4 to eliminate. This will eliminate both y and z. When we solve for x, we're going to get x is 60. Now that I have x is 60, to one of my equations, and I'm able to solve and get z is equal to 20. Now substitute 60 and 20 in, and I can solve for y. So you need to verify that the order triple 60, 40, 20 satisfies the system of equations given from the original set of equations. So the feed should contain 60 units of corn, 40 units of soybean, and 20 units of cottonseed.